Okay, so looking at part A here, we want to find the probability of B. We know that my total probability must equal 1. So if I think this is B here, so this plus these two plus this one should total 1, because that will cover all of my areas within my full rectangle here, my Venn diagram. So all 4 of those equal 1. And that's what I've got to look at. So that means that probability of B, you can hear there, that's going to be 0.5. A nice easy start. Now for part B, A and B are independent. So let's have a little think. Now we know that the probability of B is, as we've just found that, 0.5. And if I think about the probability of A, that's my A section here. There's a 0.3 and a 0.4 is 0.7. So the probability of A must be 0.3. And that's quite important. Now, for these to be independent, the probability of A times the probability of B would be equal to the probability of A intersection B. So this is if independent. Now, probability of A times probability of B is 0.3 times 0.5, which is 0.15. Probability of A intersection B, well, this is actually the value of P and Q. I'm going to put this in black here. Okay, that is my intersection of A and B. Now, I can see that 0.04 and 0.06, this totals 0.1. Now, I know the probability of A, as we already discussed, is 0.3. So P plus Q, this P plus Q must be equal to 0.2. And that'll be useful for later, but for now we know that our intersection is 0.2. And since 0.15 does not equal 0.2, A and B are not independent. Okay. Now, part C, we're told that probability of C given B is equal to that probability of C. And this is equal to the probability of C intersection B over the probability of B. Now, C intersection B is where C and B obviously intersect here, which is just P. Probability of B we know is 0.5 from the first part, and probability of C we can see, and I'll just put that up now, is this full circle here. So 0.06 plus P. Now it's a matter of rearranging and essentially making P the subject. So I'm just going to multiply by the half, and that will give me then 0.03 plus a half P. Taking away a half P gives me a half P equals 0.03. So actually P is 0.06. Kind of went the long way round there. I'm sure I could have done that a little bit quicker. But anyway, that is P done. Now, if you remember from earlier, we did talk about how P plus Q equals 0.2. So that means that Q equals 0.14. Now, part D. tells me that A and D are mutually exclusive. So that means there can be no intersection between A and D. So that circle for A is completely out of there. But it does tell me that there's an intersection between B and D. So all I need to do is draw a circle that crosses into B but doesn't touch A at all. So an example would be here. And that's me done. Alternatively, I could obviously put it in different positions around there. They're all the same. Or I could actually have it inside the circle as well. Okay, so those are all my kind of options. I'm just going to leave it there. Okay, now we're looking at finding SXP. If I just think of the formula in terms of SXY first, that means it's sum of XY minus sum of X, sum of Y over N. And what I want to do is I just want to delete that Y and all the Y's and change them into a P. So sum of XP is here. So 2, 3, 4, 7. Sum of X is 93. Sum of P is 273. And then N is up in the question and it says it's 12. And of course we get 231.25, which is exactly what we were trying to show there. Now B, we want to find our product moment correlation coefficient, which is R. So this is going to be S, normally XY, but of course it's XP in this case, SXX and SPP, and don't forget square root. So we know what our SXP is and we know what our SXX is. We first need to find out our SPP. And that is sum of P squared minus sum of P squared over N. And don't forget these formulas are given to you. So sum of P squared is here, 6,602.72 minus, and then my sum of P is 273. That is squared and it is over 12. And we're looking at 391.97. So now we can go ahead and work out R. So we get 231.25 on the top. Then we have 148.25 times 391.97. And now all I've got to do is plug this into my calculator. And I get 0.959 to 3 significant figures. Now, just before I go any further, just be aware of this formula for R. It's correct here and it's correct in the formula booklet, and when you first meet it in your S1 book, which is on page 112. However, at the end of that chapter, I believe there is a mistake in how they've written it in the summary. So just be careful if you are looking back through your summaries that you don't use the incorrect formula. Now, part C, we want to find the regression line. So we're looking at P equals A plus BX. Now, B is normally SXY over XX. So we're looking at SXP over XX. So So both of these values were given to you in the question. So even if you made any mistakes earlier, you still will be able to get some marks in this part. And that gives me 1.56 to 3 significant figures. Now, I'm also storing this in my calculator. I'm going to store it in A, and I like to just put a little letter next to my answer, just so that it reminds myself where I've stored it within my calculator. Now, I've actually stored it in A, but I think in this particular case it would make way more sense if I stored it in B. And I can store A and A. So I'm just going to store that in B now, and there I'm done, ready for the next bit. Now we need to find A, so that is the mean of P equals A plus B times the mean of X, or the mean of P minus B times the mean of X, and that is my value of A. Now the mean of P is going to be 273 divided by 12 minus, and then we've got B, which we already know, and my mean of X is going to be the 93 over 12. And obviously with B I'm going to use the full value in my calculator. That gives me 10.661. If we keep it to 3 significant figures, 10.7. And again, I'm going to store that in my calculator. I'm going to store that as A. Now I can write down what my equation is. So it's P equals 10.7 plus 1.56x. Now, part D wants us to talk about the gradient of the regression line. So that's, in our case, this 1.56 is obviously a positive gradient, so it's increasing, and we need to go back up into the question to see what it actually means. So reading the question, number of employees in the office is X, the amount spent on paper in a year is P, and each of 12 randomly selected officers. So X, what we're looking at with the X's is the number of employees. So every time I increase X, I'm increasing the amount of money spent by 1.56. This is in hundreds of dollars. So 1 would be 100, so 1.56 would be $156. So each employee, each additional employee costs the company an extra $156. And then finally, we know it's in a year, so just want to finish with per year. And that's pretty much it for D. So part E, let's have a look what happens to this formula. So we want 4/5 of A plus a half of our B times X. And remember when I said, store these in your calculator, this is exactly why. It makes your life so much easier for this bit to make sure you get a full value. So that's what I've got there, and again I am going to keep storing these in my calculator as I go along just to be safe. And then we've got a half of B, and that's going to give me 0.7799, so 0.78 or 780 X. And again, I'm going to store that in my calculator just in case. And I want those full values. Now, we want to look at the 93 employees, and it's across 12 officers. And we want that kind of average. So we're looking at, for our value of X, is going to be this 93 over 12. So let's look at our P here. We got 8.53 plus 0.78 times our 93 over 12. And that will give me 14.57. Now, we actually also need to compare this with what it would have been originally. So original, so let's go with P original, and that was 10.7 plus 1.56, and we want to times it by the same 93 over 12, and we get 22.75. But just before I go any further, do you see now why storing the numbers in your calculator just helps you? You never know when you need it within the question. So let's get back to the question. We've now got our two values for P. Now it actually talks about percentage saving. So we're looking at that percentage difference. So the percentage is simply a percentage change. So it's going to be the difference between the two percentages divided by then the original amount. And sorry there, I almost forgot to times 100. And that gives me 35.9%. Or 36, I suppose, to the nearest whole percentage. So we want to find the median. We've got 35 passengers. I think add 1, divide by 2. So 36 divided by 2 is 18. So I'm looking for the 18th one. So it's just a matter of counting. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 53 we're looking at for the median. And this is sometimes written as Q2. Now we want to find the interquartile range. So we're looking for Q1 and we're looking for Q3. So we have 35 pieces of data divided by 4 gives me 8.75. So I want the 9th value. And again, just counting my way through 1, 2, 3, 4, 5, 6, 7, 8, 9. So 45. So Q1 is equal to 45. Now I want to find the upper quartile, so 35 over 4, then multiply by 3. And that gives me 26.25. And I always round up here, so I'm looking for the 27th value. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we're looking at 61 there. So Q3 equals 61. Interquartile range is my upper quartile minus my lower quartile. So 61 minus 45, and that equals 16. That is for part B. Now for part C we're looking at outliers. So first thing we want to do is 1.5 times our interquartile range. So that's 1.5 times my 16, which is 24. Now let's look at our lowest value. So that's going to be my lower quartile, 45, minus my 24. And that gives me 21. And my upper or largest value here that I need is my 61 plus 24. That gives me 85. So outliers, they're going to be anything that is greater than 85 or less than 21, however you kind of want to look at it. Now I probably shouldn't write it quite like that because it kind of looks like I'm looking at a group there. So let's do outliers are less than 21 or greater than 85. Better way of saying it. Now we can look on here. If I look above 85 here, we got 2. And below 21, we've got this 13. So therefore, 13, 87, 8, and 88 are outliers. Now, part D needs me to draw a box plot. So I've got all my key values here. Now Q1 is at 45. So I'm going in at 45. I'm going to put my first line in there. Q3 is at 61. Which is there. Now I'm just going to join those up with a ruler. Like so. Now 53 is my median, so I want to plot that in my box. Now when it comes to plotting my outliers, they're just going to be crosses, and then we've got 87 and 88. Now there's often mistakes with the next bit. If you remember, 21 and 85 were my limits. And what people will often do is they'll draw the next lines to 21 or 85. So, you know, drawing something like this and then going up as far as that 85. But this is wrong. So I'm just going to rub that out, because what I should be doing is those are the limits, but I need to look back in my actual data to see what I should have had. So if I look at the lower end, my smallest value that isn't a outlier is 27. So what I actually want to do is I actually want to draw this only as far as 27. And then with my upper values, 87 and 88 were outliers. 85 was the limit, but that I don't have a value there. My next smallest value or next largest value closest to that 85 that isn't an outlier is 76. And that there is where I need to draw my line to. So just as far as... And that's how you do a proper box plot. Okay, very, very important. You will actually, if you did them to these values, you would actually still pick up the marks, but it's not correct. Okay, so let's get into the habit of doing these properly. Now, part E just asks you to compare the two box plots. It's not really important, it's only worth 1 mark. There's lots of different options, and all you need to do is, as the question says, when you commented on the distributions, state the values of any statistics you to support your comment. So you could have said something like the females are generally older than the men. And then your statistics you could use is maybe the median, the as the medium is higher. Now you can look at comparing quite a few bits of data here, but you know, if I look at the median of the females, for example, that's at 50% of the females here you can see are 67 or above, top 50% there. Whereas that value is bigger than this one here, which is the upper quartile. That means this bar only accounts for 25% of the men, whereas this counts for 50% of the men. Okay, so this 50% here point is much higher than the 75% there. So you can see that, you know, if you look at over half of the females are older than the majority of the men there. So you could also compare that, the median and the upper quartile there in a way as well. But it is probably better to compare like for like in the exam. Now part F is an interesting one. So we've got to state, given reasons, what we know about the ages of the granddaughter and Andras. So we've got Anja, don't know if I'm saying that right, along with her two daughters and granddaughter. So there's four of them. Now, when all four ages are included with the other female passengers, the box plot does not change. So that means that if we're going to add in the four passengers, what we can't do is adjust any of the values. So that means one has to come in this section, one in this section, one in this section, and one in this section. Any other way, and I would be altering one of these sections by a value or two. Okay? Because it'll be taking the next value either up or down in the list. So I need to make sure I've got one in each section. Now that you know that there's one in each section, we can talk about the granddaughter's age, and then we can talk about Andra's age. So the granddaughter must be between, 34 and 56. So somewhere between 34 and 56 years old. Okay, nothing else we can really say about that. Now with Anja, she had a 23rd birthday on the day of her eldest born daughter. So we've already said this would be her eldest daughter, wouldn't it? This is Anja's section. Eldest daughter, youngest daughter, granddaughter. Now, if I look at the eldest is between, we've got 72 and 67. So if I take each of those numbers and add 23 to them, Anja must be between, so we've got 67 plus 23, and then we've got 72 plus 23. So Anja is between 90 and 95 years old. And that's what happens when I just add the 23, but I do need to go back and just check. If I look here, it actually stops at 93. So she can't actually be this one. So the final answer is between 90 and 93. And there we have the final answer in black. She is between 90 and 93 years old. Okay, so hopefully I've broken it down nicely for you there in my thinking in between each step. Okay, so we've got bag A, B and C. Mike takes a random ball from A, records it, places it in C. He then takes the ball from B, records it, places it in C. And and then finally takes a ball from C. So first now we need to complete the tree diagram. I'll just pop this on a separate page. So it's quite easy. For the beginning, we've got 1/3. 2 yellows, 6 balls in total. And then bag B, we've got 1/5 there. And then if I look at bag B after the yellow ball, it's still 4/5 and 1/5. So let's follow the paths. Put a red ball in C, put a red ball in C. So there's now 8 red balls in C. But that's all there is just red, isn't there? So the probability there is just 1, it's certain. Now coming off this yellow one here, where we've got red and we've got yellow. If I follow the path, I put 1 red in and 1 yellow in. And they started with 6 red balls, so it's 7 red balls, 1 yellow ball. So it's 7/8 and 1/8. Again, now follow my path. 1 yellow, 1 red being added in. So we've got coming off here red, yellow, 1 yellow, 1 red being added into the 6 red. So again, it's 7/8 and 1/8. And then the final path, yellow and yellow. So I'm adding in 2 yellows there. So I've now got 6 red and 2 yellows. So you can think of it as 6/8 and 2/8. Or we can simplify that down to 3/4 and 1/4. Now, Mike has exactly a yellow ball twice. So 2 yellows. So I've got to go red, yellow, 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 red, yellow, or yellow, yellow, red. So those are my options. So I'm looking at, and I'll put it in right in here, so we can go red, yellow, yellow, or yellow, red, yellow, or yellow, yellow, red. Only 3 combinations there to be able to get to 2 yellows exactly. So that means if we go red, yellow, yellow, we got 2/3 times 1/5 times 1/8. Or is plus, and we want to go yellow, 1/3, red, 4/5, yellow, 1/8, and then yellow, yellow, so we've got 1/3, 1/5, and 3/4. And there we have our probabilities, and I just need to calculate these. If I change that last one here into the 6/8, I'll have the same bottom, which makes it easy. Or of course I can just use my calculator. And of course, if you did it right, you get your 1/10 as we were expecting. So next part here, part C, probability that the ball drawn from bag A is red, given that there were exactly two yellow balls. So we're looking for the probability that it is red, yellow, yellow, and it's a given that it was a probability of 2 yellow balls. And that is the answer to the previous one. So this bottom one is 1/10, and the top one then is red, yellow, yellow. This means the top probability is 1/60. And simplifying will just simply leave me with 1/6. It is very tempting just to do this probability for this question. Just be careful, you know, it is a given that. Now, for this type of question, for part D, probability distribution, what I'm looking at is the number of yellows. So I want to work out when I get 0 yellows, 1 yellow, 2 yellows, 3 yellows. So we know that 0 yellows will just be the one possibility. So this is 0 yellows, and I can work that out. 1 yellow, well, this has got to be red, red, yellow, or red, yellow, red, or yellow, red, red. 2, well, we know that's just 1/10. I won't bother writing that down. And 3, we've got probability of 3 yellows. So this is all the calculations that I need to make. So no yellows will be 8/15. Now, with 1, red, red, yellow doesn't exist, because it goes red, 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 and there's no yellow in that last one. So we just got the 2 to work out, and these will work out to 7/20. 2, as we said, we've already done, and then the final one of 3 yellows. So it's a third, a fifth, and a quarter. And that'll give me 1/60. Now what I want to do is set this out in a nice table. So in my table, very, very simple. I want to start off with my x values and then my probability. So we had 0, 1, 2, or 3. And then it's just the values that we had. So 8/15, 7/20, 1/10, and 1/60. Then part E is finding E of x. So if you remember, that's just x times the probability. So 0 times 8/15 plus 1 times 7/20 plus 2 times 1/10 plus 3 times 1/60. And that will give me 3/5, or 0.6. Okay, let's have a look at question 5. So write down the value of E of y. Now, initially it looks like you can't do it, but these are symmetrical. Look, -9, -5, 0, 5, 9. So that if it's symmetrical, E of y is going to be in the center. So E of y is 0. Okay, so part B, we've got f of 0, and this is q plus r plus u, and that is equal to 19/30. We also know that q plus r plus u plus r plus q is equal to 1. So what we can see from this, we've got 2q plus r plus u equals 1. So I'm looking at an equation 1 here and an equation 2. Now, if I rearrange number 1 and make it u equals, I've got 19/30 minus that q plus r. And I'm going to substitute that in to this number 2. So I get 2q plus r minus q plus r and plus my 19/30, and that totals 1. So I got q plus r equals 11/30. So that's one bit of information. From that, I can go back to 1, and I can now say, therefore, u must equal 19/30 minus my 11/30, isn't it? So 8/30, or 4/15. Now, part C introduces us to a little bit more information. It tells me that the variance of y is 37. And we're going to need this now to be able to find q and r. Now, if you remember, finding the variance is squaring the x value, or in this case squaring the y, and multiplying by the probability. So minus 9 squared is 81 times q. Minus 5 squared, 25 times r. 0 squared is obviously 0. 5 squared, 25r, and 81q there. So we've got 162q and 50r. And that, of course, is equal to 37. We now actually have two equations involving q and r. If I look back to this equation here, q plus r equals 11 over 30. So all I want to do is rearrange from one of them, substitute into the other, and eliminate. So if we look at from 2, we can get r equals 11 over 30 minus q. And let's put this in equation 1. So 37 plus, apologies, 37 equals 162q plus 50 lots of 11 over 30 minus q. So we get 37 equals 162q plus 55 over 3 minus 50q. Now that will give me 112q plus the 55 over 3, and then I want to take that away from 37. So that gives me my 112q equals 56 over 3. So q is equal to 1/6. Now I'm just going to make a little bit more room, and then I'm going to substitute this q here into my second equation. And now we have 11 over 30 equals 1 over 6 plus r. So r is going to be 11 over 30 minus 1/6. And that will give me 1/5. So you can see my value of q is 1 over 6, and my value of r is 1 over 5. So part D, a little bit more confusing, but let's look at it. So the probability distribution of D is when D represents the length of OP. So if I think of O to P, we can see that it's got a x value of 12 and the y value is our y, our distribution. And obviously the length of this is going to be Pythagoras, so it's essentially going to be the square root of y squared plus 12 squared. That's essentially what we're looking at. So let's look at the possible values. So if y is minus 9 or y is 9, when they're squared, it's going to give me 81. So we've got 81 plus 12 squared, which is 144. And that's 225, so square root of 225 is going to be 15. Now the other way I can do this is with 5 or minus 5. Those squared is going to be 25 plus my 144. That gives me square root of 169, which is 13. And then my final value is 0. 0 squared is 0. So I'm just doing the square root of 144, which is obviously 12. So my distribution D here, it can take essentially just three values, 12, 13, or 15. These are the only possible lengths it can take. Now, there's two ways of making 15, and I'll put this in black here. 15 is made when we did the 81, so that's the 9, so it's a 6th plus a 6th, which is 2/6 or 1/3. Put it in the wrong place there. Now, when I'm looking at 13, that was made from my 25, which is from my 5s. So I'll do this bit in red here. A 5th and a 5th is going to give me 2/5, and that is my 13. And then the only way to make the 12 was with 0, so that was 4/15. And that is done. So part A here, we've got a normal distribution, clearly looking at H for height, distributed normally, and then we have a mean of 25.1 and a standard deviation of 5.5. So obviously we use the variance in the question there. Now we want to show the probability that H is greater than 30.8, and I want to use my value of Z. Now I know that Z is X minus the mean over the standard deviation. So that is 30.8 minus 25.1 over 5.5. And that is 1.036. Now, actually, I did actually skip a step because I do like to look at the graph. So just a really rough idea of the graph. The mean initially is 25.1. We want greater than 30.8. So we're looking at that section. That means that when we come to our values of Z, which is our 1.036 here, we're going to end up wanting 1 minus. So this is going to be the same as Z is greater than my 1.036, and this is the same as 1 minus the probability that Z is less than 1.036. And then it's a matter of looking it up in my tables. So this is really looking at 1.04. So we've got 1 minus 0.8508. And that then gives me 0.1492 from tables. Okay, now that 1.036 is obviously between 1.03 and 1.04, closer to the 1.04, but almost halfway. But you don't need to do interpolation with the tables. So if you've got your answer from the tables, this is what it will be. If you use your calculator, you'll be able to get a more accurate calculation or answer. Now, I'd normally put that answer up, but I don't actually have that calculator with me at the moment as I'm traveling. What I will do is that when I do get back home, I will put it up in text what the values from the calculator are. And finally, I should actually write this as 0.15 as that's what the question was asking. So part B, this Yang, I'm not sure if that's how you say it, decides the smallest 5% of the books, and the books that are taller than that 30.8 will not be placed on the shelf. So if I think of this again, just a very rough diagram, 30.8, that's what we've already looked at, and that's 25.1 in the middle there, and then 5%. So we know that's 0.05. So that's what we're looking at. And then, of course, we want to know how many books are, or we want to find the range of heights of books that are going to be placed on the shelf. So what we're actually looking for is we're looking for this value here. So that is that z being smaller than some number is going to be equal to 0.05. And for this one, it's very useful to use the second table. So probability of 0.05 gives me a z value of 1.6449. Now, due to where this is placed here, which is left of my mean, I know that this z value is going to be a negative z value. Just write that a little bit better there. It's a negative z value. Now, what I can do is, that's going to be my value of z. So if you think about it, this is going to be equal to x minus my mean all over my standard deviation. And I want to rearrange to make this x equals. So my minus 1.6449 times 5.5, then add 25.1, and then I get 16.05. And going to one decimal place like the other one, 16.1. Now what that means is my range is between 16.1 and 30.8. So this is what we're looking at. This middle bit, which I'm going to put in black here, must therefore be the size 0.8. We're in the ratio of 2 to 3 to 3, which, as we can see, totals 8. That means we must be 0.2 for our small. Our medium must be at 0.3 and our large must be at 0.3. So if I think here, the start of the median, or medium, I should say, books, is, if this is my 0.05, then this is 0.2, and this is the start of the medium, and it goes up by 0.3, which is just going to take me just past the middle. So this section here is my 0.3, which is my middle. That's my medium. So if I'm looking at this one here, I'm looking at a value less than 0.25. So probability here will be 0.25. And at this point, my probability will be at 0.55. And those are the two values I need to do to be able to find my D and my M. Now, first thing I need to do is actually find the Z value where this 0.55 is. So if I go to my tables, and I don't want to go down the Z values, I need to go down the probability side. So I'm looking down the probability side for the value closest to 0.55. And I can see two, 0.5478 and 0.5517. Now when I look at them both, I can see that this is 22 away from my 0.55, while this is clearly 17 away. This will be the closest value, and the Z value there is 0.13. So that's my value of Z at this point. So my Z equals X minus the mean over the standard deviation. My Z is 0.13. My X is actually D. My mean is 25.1. My standard deviation is 5.5. So now it's just a matter of starting with my 0.13 times by 5.5, then add 25.1, and that will give me 25.815. Now this said 25.8, so that's what we've got to one decimal place. Now let's find m. And very much like the last one, we want to find this value of z. That represents my 0.25. Now this, obviously we don't really deal with it in that side. It's going to be the same as this value here when this is 0.25. And I can look that up in my second table. Actually I cannot, it's 0.2 and 0.3. So I'm actually going to need to use the first table again. So 0.25, that would mean that this is 0.75. So that's what I want to look up. So I'm looking down the probability values for 0.75. And there's two. So 0.7486 and 0.7517. And if I look, this one here is 14 away, this is 17 away. So I want this first one, and that's 0.67. So this is 0.67. Now it's supposed to be on the left, it's down here, the smallest one. So we actually want it to be the negative value. So we've got minus z equals x is now my m minus my mean, which is 25.1, over my standard deviation, which is 5.5. So minus 0.67 times 5.5, add 25.1, and then that will give me that m is equal to 21.4. I will do that to one decimal place like the others. So we can see that he wants 2 shelves for small books, 3 for medium and 3 for large. So the largest small book is this one. So assume that there would be one of these on each of the 2 shelves. We got 2 lots of 21.4. He wants 3 medium shelves, so we got 3 lots of 25.8 as the largest mediums, and the largest large books 30.8. So that's what I'm working out here, and this equals 212.6. Now that's just the books. Now I need to add the shelves. Now it tells me that the shelves are 1 centimeter thick, and there's 8 of them, 2, 3 and 3. So I've got 212.6 plus 8 centimeters, so 220.6, or to 3 significant figures, 221. Hopefully you found this useful. Let me know in the comments anything else you want me to go through for your revision.